Welcome to my video series Problems for JEE Main and Advanced and for different state level joint entrance examination. Now, the chapter Theory of Quadratic Equation is going on, and today it is part 8 of that. First problem is problem number 37 of that chapter, and the problem is if ratio of roots of x square minus px plus q is equal to 0 and x square minus rx plus s is equal to 0 are same, then which one is true? Number one, q plus r is equal to s plus p. Qr square is equal to sp square. Qr square is equal to plus sp square is equal to 0 and pr is equal to qs. Now let us see the problem once again. If the ratio of roots of this and that are same, ratio of the roots of this and that are same, in that case, which one is true? Suppose alpha beta are roots of that and gamma delta are roots of this equation. Then we are given one extra condition that ratio of the roots of this, that is alpha by beta, and ratio of roots of that is gamma by delta. If ratio of the roots are same, then which one is true? From there, we have alpha plus beta is equal to P and alpha beta is equal to Q. And from that, gamma plus delta is equal to R and gamma delta is equal to S. These are given and this thing also given. From this relation, we have to find from these three, these 4 and 5 relation, we have to find a relation involving coefficients. So we have to eliminate roots. So from here, by componendo dividendo, we can obtain alpha minus beta by alpha plus beta must be equal to gamma minus delta by gamma plus delta. Now value of this, value of that is known from there, but this is not known. For that purpose, squaring both sides, alpha minus beta whole square by alpha plus beta whole square, gamma minus delta whole square by gamma plus delta whole square. This can be written as alpha plus beta whole square minus 4 alpha beta. Now this is known, this is known. So from this I can write that by alpha plus beta itself is known, so keep it intact, is equal to, same way it is gamma plus delta whole square minus 4 gamma delta by gamma plus delta whole square. Now this become, this by that is 1. So 1 minus 4 alpha beta is q by alpha plus beta whole square is p square is equal to, this by that again 1. So 1 minus 4 gamma delta is s divided by gamma plus delta whole square, r square. So 1 cancels. So after that negative will be cancelled and 4 will be cancelled, so that we have q by p square is equal to s by r square. After that, we get qr square is equal to sp square. So second option is correct. Option B is correct. Now next problem. Problem number 38. If alpha beta are roots of x square minus a into x minus 1 plus b is equal to 0, then the value of 1 by alpha square minus a alpha plus 1 by beta square minus a beta plus 2 by a plus b, how much? Options: AB, 2, 0, A by B. In this case, the problem is, it is problem number, I think it is 38, right? It is 38. If alpha beta are roots of this equation, and then to find the value of that, and options are in terms of a and b, that is coefficients. Now the equation is x square minus ax plus a plus b is equal to 0. Now, as because alpha and beta are roots of that, alpha and beta will satisfy the equation. That is, we must have alpha square minus a alpha plus a plus b is equal to 0. By same way, beta is also a root of that, must satisfy. That is, beta square minus a beta is equal to, now this become the expression 1 upon alpha square minus a alpha is minus a plus b plus 1 by beta square minus a beta, same 1 by minus a plus b plus 2 by a plus b. They together is minus 2 by a plus b and plus 2 by a plus b. So they cancel and answer is 0. So our answer is 0, that is option C is correct. Next, problem number 39. The problem is, apart from 0, number of roots of e to the power x plus x minus 1 is equal to 0. Apart from 0, number of roots of this equation, but not the roots, but number of roots. And option is 0, 1, 2, and infinitely many. To The problem is here, this is a equation, not quadratic equation. It is exponential. One part is exponential, other part is algebraic. The number of roots of that equation, how much? 1 or 2 or 0 or apart from 0. But 0 is the root of that, it is given because e to the power 0 is 1, cancels with that. So this is 0. So 0 satisfies it. The apart from 0, but other than 0, how many roots are there? We know that if a function is of the type fx is equal to gx, then number of roots is y is equal to fx and y is equal to gx. These two cards, this and that, meets in uh, how many ways? I mean, uh, if suppose y is equal to fx is a curve like that, and y is equal to gx is curved like that, they meet at these 2 points, so it has two roots. Now, in the present case, let us take y is equal to e to the power x, and this is y is equal to x minus 1. So y is equal to fx, this is y is equal to gx. Now let us draw a rough sketch of that. Standard, these two are very standard. Y is equal to e to the power x. It is actually, it starts from minus infinity to meet y-axis at the point at the point 1. After that, they moves to infinity. Now for this one, it is, oh sorry, y is equal to, no, it is there. Fx is equal to gx. So y is equal to that, and this should be taken to that side. It is 1 minus x. Now y is equal to e to the power x is that the curve. And this one is x plus y is equal to 1. It means it meets x-axis at the point 1, y-axis at the point 1. This is 1, this is say 1. Say it is y is equal to x plus 1, this is y is equal to e to the power x. Now clearly they meet there, which is at the point x is equal to 0. So x is equal to 0 is a solution of that. But our question is, apart from 0, in how many number of roots of that equation? Apart from 0. So 0 cannot be considered. So apart from 0, these equations have no solution. So first option is correct. This type of problem is very, very important. Now, problem number 40. Problem number 40 is, if alpha, beta, gamma are cube roots of a positive number p, then for any xyz, the value of x alpha plus y beta plus gamma z gamma by beta x plus gamma y plus alpha z is options minus 1 plus root 3I by 2, minus 1 minus root 3I by 2, 1 minus root 3I by 2, and last option is 1 plus root 3I by 2. Let us see what is the exact problem. It is given that alpha, beta, gamma are cube root, not cube root, is alpha, beta, gamma are the cube root of a positive number p. Cube root of a positive number p. It means, say, x cube is equal to p. By solving this equation, we get three roots, and one is alpha, that is beta, that is gamma. So alpha, beta, gamma are cube root of p, and x, y, z are any three positive, not positive, any three real number. Then the value of that. Options are there. Actually, that problem is a combination of quadratic equation and uh, and complex number. In most of the cases, in many cases, in any competitive exam, problem will be given combining 2 or 3 chapters. So in this regard, this problem is also very, very important. We know that cube root of unity, that is x cube is equal to 1, its roots are 1 omega omega square. What is 1 to understood easily, and what is omega? Now omega is equal to minus half plus root 3 by 2I, and omega square is its conjugate. It can be understood easily, very easily, from the chapter complex number. Not yet done here. Now, to solve this in terms of omega, omega square, etc., let us put x is equal to p to the power 1 by 3 into y. Put x is equal to p to the power 1 by 3 into y. Putting it here, this is p y cube is equal to p. That is y cube is equal to 1. P cancels. So I can take advantage of this equation. Its roots are 1 omega omega square. Y is equal to 1 omega omega square. But our original variable is x. So x is equal to p to the power 1 by 3 into y. I mean, x is equal to y means 1. Number 1. Number second one is p to the power 1 by 3 omega, and third one is p to the power 1 by 3 omega square. So roots of that equation is this. One is p to the power 1 by 3, other is p to the power 1 by 3 into omega. This. Now the given expression is this. We have to find value of that. So alpha x plus beta y plus gamma z by beta x plus gamma y plus alpha z is equal to, first root is alpha, in that case this one, so only p to the power 1 by 3 into 1 plus second one is beta, which is that, so it is equal to p to the power 1 by 3 into omega y. Third root is gamma, that is this one, so p to the power 1 by 3 into omega square into z divided by beta x. Beta means p to the power 1 by 3 into omega x plus gamma p to the power 1 by 3 omega square into y. And third one is alpha, that is this, p to the power 1 by 3 into z. Now clearly p to the power 1 by 3 cancels, so that 1 plus omega y plus omega square z by omega x plus omega square y plus z is equal to, oh sorry, this is uh, one, x must be there, x. Now from denominator take omega common, তাহলে x plus omega y plus omega square z, and from denominator take omega common, x plus omega y, and z is simply 1 into z, 1 means omega cube z, because omega cube is equal to 1, so that it is omega cube 1, omega is taken common, so omega square z. Now you see this part cancels, so answer is simply 1 by omega. Again 1 is equal to omega cube, so it is omega cube by 1 omega, so omega square, and its value is this, minus half minus root 3 by 2i. So option is B, second option is correct. Next, problem number 41. If, problem number 41 is, if ABC are in AP, A, B, C, they are in AP, then roots of x square minus 2bx plus c is equal to 0 are options minus 2 comma minus c by a. This is a. Second option is 1 comma minus c by a, minus 1 minus c by a. Fourth option is 1 comma c by a. Here in that problem, one quadratic equation is given, x square minus 2bx plus c is equal to 0. And about ABC, it is given that ABC are in AP. That means A plus C is equal to 2B, that is A minus 2B plus C is equal to 0, because A plus C is equal to 2B. Then to find the roots of that given equation, roots of that. Now subtracting we must have a into x square minus 1. This is negative, this is positive, plus minus 2b into x minus 1. This cancels. That is, it is a into x minus 1, x plus 1 minus 2b into x minus 1 is equal to 0. So x minus 1 is a factor, is equal to 0. Hence, x minus 1 is a factor. That is, x is equal to 1 is a root of the given equation. So 1 is a root. Next, to find, and because it is quadratic, it has another root. Let us find what is the another root. We know that product of the roots is c by a. Product of the root. One root is alpha 1. Just now we prove it. One root is 1. Suppose second root is alpha. So their product is that. So second root is c by a. So roots are 1 and c by a. So option D is correct. Next. Problem number 42. Problem number 42 is, if 42, if 2p square is equal to 5p plus 3 and 2q square is equal to 5q plus 3, then, and p not is equal to q, then the quadratic, then obtain the quadratic equation whose roots are p square and q square. Here, simply this relation is given, that relation is given. This is quadratic in P, this is quadratic in Q. And given that P naught is equal to Q, in that case, we have to obtain a quadratic equation whose roots are P square and Q square. From this one, it is clear that P is a root of 2x square minus 5x minus 3 is equal to 0. Because P satisfies it, as because it is given. Similarly, from the second relation, we can claim that Q also a root of that, because 2q square minus 5q minus 3 is equal to 0. So that given, in fact, it is given that PQ are roots of that. So we have P plus Q is equal to 5 by 2 and PQ is equal to minus 3 by 2. We have to form an equation whose roots are this and that. That is x squared minus the sum of the roots into x plus product of the roots. That is, we know we have value of p plus q and pq. So express it in terms of p plus q and pq, so that it is equal to x square minus, it is p plus q whole square minus 2pq into x plus pq whole square is equal to 0. Put values of p plus q and pq. This is x square minus 25 by 4, this one, p 5 by 2 whole square minus 2pq is 3 into x plus pq whole square is 9 by 4, that is x square minus 25 minus 12, that is 13 by 4x plus 9 by 4 is equal to 0. So equation is 4x square minus 13x plus 9 is equal to 0. This is answer. Oh, I have forgotten to give the options. So this, in fact, this is our answer. Okay, let us stop today, and I request you to like, share, and subscribe my video channel. Thank you.